things for sale. No, no, and no. Our speaker tonight is Dr. Andy Hansen down here, and with me. And Andy is involved in I call it the photographic business. And tonight he's going to talk about from balloons, pigeons, and kites to drones. Isn't that the buzzword today? Andy, welcome aboard. Thank you for being here with us tonight. And I'll turn the floor over to you. Andy, you're right.
Yep. Okay, I think I'm all right. Can everybody hear me? Okay. What I want to talk to you today is just give you a very brief run through on a number of different subjects, which all related to aerial photography. I'm a user of aerial photography, and occasionally I take it myself, but I'm not a professional aerial photographer. My expertise is in aerial photograph interpretation. So a lot of what we do when we're interpreting photographs is we have to decide what it is we're looking at. And part of that means we have to look at the way the photographs were taken, the equipment that was taken, because all of that affects the objects, the features that we're looking at on the imagery. I got interested in aerial photography because I wasn't able to become a pilot. My dad was in the RAF in Singapore during the Malaysian insurgency, and he then went on to become an aircraft mechanic with BOAC and then British Airways. And as a young kid, I was allowed to tour the hangars and go on planes and actually go in and have a look at the workings. You can't do that now with security, but when I was young, I went all over aircraft, and I really got hooked by the flying bug. So being able to interpret aerial photographs is second best to being a pilot. But I fly around in my mind and looking at the images. So I've used it that way. So let's just go to the other thing I want to acknowledge is that I believe online we have someone called Kevin Stiles, who is an aerial photograph interpreter originally from Sydney. He now works in Hong Kong. I've worked with him for over 40 years. He has taught me a lot about aerial photograph interpretation, and I hope it's been reciprocal. So I just want to acknowledge that Kevin has been really quite a major influence on my life. He's probably going to have to disappear quite soon because he's in Hong Kong on Zoom, but he'll be disappearing off to go to another meeting. But all right, thank you very much, Kevin. Okay, so next slide, please. So we're going to have to be a little bit. I've got about 40 slides, so some of them we'll whip through fairly quickly, some I'll say a bit more about them. This is one of the earliest bird's eye views in art. Now, this is a different perspective. We're used to looking at the television, newspaper photographs, bird's eye views, aerial views. They're second nature to us now. In the medieval era, that was very unusual. The only way you could get a bird's eye view was by going up a church tower and looking across. For most people, they were very unfamiliar with that perspective. And so in 1500, a woodcut with an aerial view, which must have been in the artist's imagination because he couldn't get that high. So it's a new way of showing an aerial perspective. So next one. Now, just my personal involvement with aerial photography. The top one is me in 1986, where we needed to take some photographs of a rock cliff. Now, the trouble with rock cliffs are that they're very steep. And if you put a normal aerial survey camera mounted vertically, it doesn't have a very good perspective on a near vertical rock cliff. So we managed to get an airworthiness certificate and a frame and mount this RC8, I think that one is, people who are more familiar with it might correct me with that. It might be a 10.
RC10.
It is an RC10. Okay. Yep. So it's a long time since I was involved with that. We put that on a helicopter and we were able to fly and take some good oblique photographs from quite close to of a rock cliff. With that, we were able to actually measure some joints and joint orientations on the rock cliffs. The bottom one is a more recent project, which I'll actually be mentioning a bit later. So now we've gone from a big, large format aerial camera to a small handheld camera, and I could sit on the edge of the helicopter and actually photograph directly. Next one. There are quite a number of museums that have interesting collections of aerial photography. A lot of it is related to spying and reconnaissance. I've just taken two examples from Washington, DC. You've got the International Spy Museum, which has some interesting aerial photography and exhibits, and also the National Air and Space Museum, the Smithsonian in Washington. I know there are some in the UK, and I don't know if there's any in Australia, which are specifically related to aerial photography. That will be interesting. Okay, next one. Now, so what are we dealing with? Most of you will be, if you've been involved in the business, you'll know what these are. This is an oblique aerial photograph. We see the sides of everything. It's a fairly familiar perspective for most people. Next one. And this is the more unusual one, which is a vertical aerial photography. This is what's used very widely for mapping. The main thing about the vertical aerial photography is a central perspective. So all the tall buildings are distorted away from the center. That gives us parallax, and that allows us to see in 3 dimensions when we look at a stereo model. And if we know the geometry of the camera, we can actually start using that to take measurements. And that's what a lot of surveyors will now use for doing mapping. Next one. Now, just a quick history of photography. This is the first known photograph. It was taken with a bitumen emulsion dissolved in lavender oil. The exposure was 8 hours. And the interesting thing about it, you can see the building on the left and the building on the right are both illuminated. And that's because the exposure took all day. So the shadows don't quite match what you would sort of expect from a photograph. Next one. This is so that first photograph was taken by Joseph Nicephore-Niepce. Now, he was only recognized as the originator of photography in 1952. Up until then, Daguerre got all of the recognition, and it was only some very dedicated historians in France going through the archives who were able to rightly point out that Niepce was actually worked with Daguerre, but was actually working in advance of him. Now, this is one of the very first photographs that Daguerre produced. Also has a very long exposure. And this is a busy Paris street. Now, the interesting thing is that all of the traffic and the pedestrians have disappeared, except for one person in the bottom left-hand corner who was standing still, having his shoes cleaned. And that meant he was in one place long enough to be recorded on the exposure. So exposure time was a very significant problem in the early days. Now, next, please. Now, the exposure time was obviously a problem when people started thinking about how they were going to take photographs from the air. This was a Mr. Tourneschon, colloquially known as Nadar, who started taking balloon photographs. He started taking photographs in 1858, but some of his earliest photographs don't actually survive. Next one, please. This is the oldest photograph of his that actually survives, which is 1868, but that post-dates some other photographs taken elsewhere, but he actually had started earlier on. And that's an example of the Arc de Triomphe in Paris, and that's a woodcut of his balloon. Next one. Meanwhile, in America, what's his name? William Black was also taking aerial photographs from a balloon, and these ones predate the Nadar ones, but I think only because of the historical record. He published a book, and this with this particular image in it. It's called "Boston as the Eagle and the Wild Goose See It." So that was the first photograph. Now, these were taken with glass plate photographs, and they used the wet colloidal process, which meant that the glass plate had to be manufactured and exposed at the same time, which meant they had a dark room on the balloon. So it was not something that you could just pre-prepare. So it was quite an effort. William Black took 8 plates and only one of them actually worked for this particular flight. Right, next one. We can move on from balloons and look at some other devices. This is a kite that was fitted with a glass plate camera. They must have, by this stage, worked out how to stabilize the emulsion a little bit more because it would have started drying out. The camera had a fuse and a little flag on it. And they set the camera up, lit the fuse, put the kite up, and they waited until a little flag went up to show that the fuse had burnt out and the photograph had been taken. And they then pulled it down quickly and to get the glass plate processed. Next one. This is his kite photograph over La Brugère in 1888. So we're 20 years on from the kite photography. So there's been a number of developments in the film emulsion since then. Next one. We also have people experimenting with rockets to take an aerial perspective. Alfred Mao got a patent for one. This is a photograph taken through a window in the top of the rocket. So again, it's another aerial perspective. Next one. Now there was a US patent also filed for rocket photography. We're not sure whether it was actually ever used, but there is an item in the patents office. And this is another example from over North Germany. This time the rocket appears to have gone slightly higher, and the image is rather better than the first one. Next one. They did try and use the rocket camera in, now when was it? It was, the Turkish-Bulgarian War in 1912 to 13. And this is the German or the Prussian military corps of rocketeers firing the rocket. It could reach an altitude of 1 kilometer, which is quite significant if you want to take an aerial photograph. But they decided that it really wasn't a very practical medium. And by then, aircraft were becoming more viable as a medium for cameras. Next one. Here's another example of some balloon photography. They were getting quite sophisticated with cameras. So here are the pyramids in Egypt in 1904. Next one. Now this is one of the more better known examples of early aerial photography. This was San Francisco in ruins, taken by George Lawrence. Now he used a very big camera, and to get that up, he had a string of 17 kites. Next one, please. So there is the big camera. It took a panoramic image, and there's a string of some of the 17 kites that we used to get it aloft. So really quite an effort, but that is the only aerial photographic record that we have of the San Francisco fire, which the big fire of San Francisco, which predated the earthquake. Next one. Now, there was also another few interesting little experiments. This was Julius Neubranner's patent for a small camera that could be flown on a pigeon.
Is his destination.
Someone hasn't turned their microphone on mute. So one of our Zoom. Keep going. Okay, kite photography. The next photograph shows one of the photographs taken with the pigeons. We can move on. That's okay. And you can see that there's actually the wings have captured the edge of the image. Right, next one. Now, in addition to the aerial photography, let's just look at a parallel technique, which is stereo photography. Stereo photography became very popular in Europe and America in the mid-19th century. And this is an example of a stereo photograph of a nice tree-lined road. Next photograph. Next slide, please. And this is a stereo camera and a stereo viewing device. So these were very popular in the 1860s, 70s, 80s. But as those of you who are familiar with it, if you look at a photograph, two photographs taken from a slightly separate position, if you look at it with the photograph being put on each eye, you will see a stereo image, a three-dimensional image. So a lot of this was initially a social gimmick, but in fact the surveyors can use this as a technique. Next one, please. Now the military, of course, liked the idea of being able to make maps, and so Group Captain Frederick Laws discovered that if you take a sequence of photographs, that will give you an overlapping sequence of stereo images, which allows you to do to build a model, have a three-dimensional image of a much larger area. Next one. This is basically the essential idea that you take a line of photographs with at least 60% overlap. You need more overlap if you've got mountainous terrain, and that will allow you to have stereo coverage of the whole project. Now, next one. So in the First World War, they started taking lots of aerial photographs, and this is a camera. Originally, they were handheld, and they decided then that they'd be able to mount them on the side of the aircraft so they can start photographing downwards. Next one. And if you have these vertical photographs, you can start making maps. And this is the start of a survey of a French airfield in the First World War. Gives a very map-like perspective. Next one. And of course, it was very important that they monitor what was happening with the trenches and the reconnaissance. So this is a photograph taken of both the Allied and the German trenches in this is Quest des Cavaliers de Courcy. So and there's a date on it. Now there were in the First World War, there were over 500,000 aerial photographs taken. They became exceedingly valuable. They were being taken several times a day over at the trenches because both sides, the Germans were doing it just as well. Very important to try and monitor what the other side was doing. Next one. The other thing that aerial photographs give us is a historical record of changes and what's happening. Now, this is the village of Passchendaele before or at the start of the war, and then Passchendaele at the end. The lower photograph is the same village during the conflict, and that is an absolutely drastic change. I mean, there's nothing left. You can still see the roads just about, but you can't really see anything else. Next one. Now, in Australia, some of the earliest aerial photographs were taken in 1920 by Milton Kent. That predates Charlie Pratt and all of his expertise, but there was he set up an aerial photo business. If we just take a look at the next one. Sorry, that photograph is in Sydney, and that is the Pastoral Association building. So that's an enlargement of it. So if you zoom in, take the next one, that's an enlargement of it. So it's actually quite clear for 1920s, because they were very useful for military technology. There were a lot of advances in the aerial cameras, because like most things, if there's a need for them, there's a lot of development. The development occurs rapidly. Now, let's move on. Now, this is an aerial photograph taken of Hong Kong. When I was in Hong Kong, we used a lot of the historical aerial photography to give us a sequence of changes in the urban area and the rural areas. But in 1924, a seaplane took off from HMS Pegasus, flew around Hong Kong and did a mapping survey of the territory. It's not very clear, but one of the features of this photograph is that the sections of the image are slightly blurred. And that's because the cameras at that time didn't have vacuum plates to hold the film firmly in position. So there was a little bit of warping of the images. But they are still an exceedingly good historical record from 1924 in Hong Kong. A lot of records got destroyed in the Second World War when the Japanese occupation. And so the aerial photographs are a good record of pre-war conditions. And we found them absolutely invaluable when we were trying to work out the history of development in the urban area. Next one. Now, this is a Luftwaffe photograph of the Firth of Forth. If you look at the bridge, you can see that there is the characteristic shape, the dome shape of the Firth of Forth bridge. But what you're seeing is actually the shadow, because it's a vertical photograph. So that is there is a small mark, you probably can't read it from there, on the middle span of the bridge. It actually says flak. So they're targeting for the German bombers and warning them where the gun emplacements are. So it wasn't just the Allies who were doing it, the Germans were doing it as well. In fact, a lot of the images that were found in the Luftwaffe inventory were taken pre-war. So the Germans had been collecting their archive in advance of 1940. This one is the Bismarck. This was taken by, let me see, there was a lot of aerial survey looking for the German battleship Bismarck and its support heavy cruiser, the Prince Eugen. They were trying to find the German fleet before it could escape into the Atlantic and wreak havoc. This was in Norway. But a reconnaissance Spitfire managed to photograph the Bismarck in this field, and they notified the Royal Navy, who then were able to attack it as it left. Next one. So this is this is a Lockheed Lightning painted with the aerial reconnaissance colours, which is, I think most of us will recognise that from some of the old war photography. they basically, the aircraft were made as light as possible, no armaments, nothing extra, so they could fly as fast as possible. And the pilots were exceedingly brave because they had no defense whatsoever, like, other than to fly low and escape, low and fast, or find a cloud and just escape. So some of the reconnaissance pilots were really perhaps some of the bravest in the war. They did a really difficult job. Okay, next one. Now this is getting on towards the interpretation. There was not only were the Allies and the Germans as well, and the Japanese, taking lots of aerial photographs, there were teams of people back in the offices looking at the images, trying to work out what's going on, what they meant. Now this one here is the photographs where they discovered the V1 and the V2 launch sites at Peenemünde. So again, absolutely critical to the war effort to find out what's going on before they even knew what the V1 doodlebugs were. So once they found them, of course, they could then direct the bombers in and try and destroy the facilities. So the area, more aerial reconnaissance to look at the effect of the damage. Next. Moving on to the 50s and 60s, there were attempts to use much higher altitude rockets to capture imagery. The Corona rocket was a semi-successful program in the late 50s, 60s. The idea was that the rocket flew, took the photographs, dropped a capsule, which was then retrieved in the air with the images. Next one. The U-2 spy plane is still being used. The U-2 still flies. I watched a video the other day. It takes 35 hours of maintenance for each hour of flight that the U-2 takes. So it's a very old lady. It's still flying. But it was also absolutely critical in identifying the missiles in the Cuban Missile Crisis. So again, another quasi-military application. Next one. Now, most of us have seen on the news drones, UAVs, unmanned aerial vehicles. And these are some military style drones. That's where all the money goes for these big, I've put the photograph in there twice, sorry about that. But I won't really cover the military aspects. I'll do more with the things that we're more likely to be using. Next one. So there's two main styles of drone. You have the fixed wing and the single or multi-rotor. This is a fixed wing aircraft. They can cover quite large areas with sequential photographs very cheaply. A drone like this costs about $7,000. So it's really not that expensive to use. And they're widely used for flying mine sites, for doing things like stockpile surveys. Next one. This is two of the bigger drones. These are multi-rotor. Generally, the more rotors it has, the heavier weight it can carry. This one, the one on the right, is carrying a conventional digital SLR camera, which are quite heavy. The drone on the left, I was actually using for a project in the last few months. That is a DJI Mavic 2 drone. It's got a 24 megapixel camera, very high resolution. I was doing a survey where I was getting accuracies of a few millimeters from those photographs, which is really quite impressive. The lump that you see on the top of the drone is something called an RTK receiver, real-time kinematic. That allows corrections to GPS signals, which gives centimeter accuracy to the position of the drone, which is also very valuable when you're trying to get high precision measurements from aerial photographs. Next one. So here's a few more mapping cameras. Some of you will be more familiar with them. It's a nice big mount, a single lens camera, which was the standard for many years. Increasingly now, particularly with computational techniques, we're starting to deal with multi-camera, multi-lens cameras. Next one. Now, this is one of the things we have to do when we're doing with it, when we use photogrammetry. Photogrammetry is the art of taking measurements from photographs. One of the things we have to do with that is have a very high geometric correction of the lens, the distortion due to the lens. If we know what those distortions are, then we can start building multi-lens cameras, and you collect subsamples. This particular camera has 8 sensors on it. It takes the images from the 8 sensors, performs the correction on the fly, and saves it as one image, one high resolution image built up from all of those individual cameras. Now, with a camera like this, you can actually have an onboard computer on the plane, and by the time the plane lands, it lands with the map finished. So it's taking the photographs and doing all of the geometric processing.
Who builds that?
Sorry?
Who builds that?
That's Vexel, that's an American company. But this is quite a big camera. You need a small light aircraft to fly this one, but they are now making cameras that are about that size, which you can fly in very small aircraft or even big drones. And increasingly now, some of the cameras on drones are becoming really quite high resolution.
Andy, why are the lenses different colours?
Well,
Three of them.
okay, well, the other thing that they have with these systems, you have the dynamic range on the dynamic range is the range between light and dark that you capture on an image. When you start having these colored filters, you can increase the dynamic range. So you're actually, instead of having an 8-bit image, so each image has 8 bits of ones and zeros, they can have 12 and 14 or 16-bit images. So they're covering a much wider range. So if what you're looking at is in very deep shadow, they can post-process it and make it very visible. And similarly, if you've got something which is very bright, you can tone that down. So you can flatten out the contrast across the whole image and see areas of light and dark. And these different colors, the 4 cameras across the middle, they're panchromatic, they're black and white. So they take the basic pixel pattern, and then the colored ones around the edge color it in for you. So they supply the color. The color resolution is lower than the black and white. The black and white has the highest resolution. That's what you do your measurements from. But if you want a pretty picture and know what the colors are, you can fill in the pixels with the lower resolution colors. And okay, next one. So one of the other thing they're doing with multi-lens now is you have your central vertical camera, and you can have cameras facing obliquely around the edge. This is one of the major uses of this is something that they call cityscape building. So the picture on the right is a model. It's not real. If you look at the car park, all the cars are flat. So the cars are flat because they've not been built into a 3-dimensional object. But the sides of buildings are all there in detail. Now, you can't do that from a vertical photograph because the vertical faces don't show up very well. So if you have these oblique cameras as well, you can build your 3D model from your vertical survey, and the flat faces you populate with your oblique images from the side facing camera. And again, it's all done on, it can all be done on the fly, literally whilst they're flying. So cityscape and 3D models is becoming very useful. If you go to some of the government websites, you can actually look at 3D models of areas. Even Google Earth, if you turn on the 3D models, you will see 3D buildings. But some of these cityscapes, I mean, quite a number of businesses are making a good living out of making these 3D models. Okay, next one. Let's just have a look at some interpretation. As I said, I'm an aerial photograph interpreter, and using historical sequences of photographs is absolutely valuable. Now, the photograph on the left was one of those 1924 images that I mentioned from the HMS Pegasus. The one on the right was the same site in 1967. That particular site was, if you look at it, there's a big flat platform in front of the building that suffered a landslide. The front part of the platform fell away. And the question is, why did it fall away? Well, the reason it fell away was, if we go back to 1924 and we see that big white patch on the left, that white patch is a fill slope. So that was made by people tipping. They cut the flat platform off the top of the hill, tipped the soil over the slope, no compaction, no nothing. It was just loose fill. Loose fill isn't very strong. And that's basically why the landslide happened there. You can see the extent of the loose fill in these old photographs. And so going through a historical sequence of photographs allows us to build a construction history of sites. Next one. Now, let's just look at a couple of projects that I've been involved with using aerial photography. This was in 2014, there was a very, very heavy rainstorm over Hong Kong. Almost a metre of rain fell in about 8 hours. Absolutely phenomenal heavy rain. And this was the pattern of landslides that occurred. Luckily it was on, it was in the Cyclone Peninsula, so quite a long way away from the urban area. If the same rain had fallen in the urban area, it could have been really quite something. But this was out in the New Territories, and the government wanted to investigate, to make an inventory of the size and distribution of the landslides. So next one. So I basically flew in a helicopter. That was the photographs of me on the first slide was for that job. We did 2 orbits of this hill. I took handheld photographs, and from those we were able to measure make an inventory of the position of all the landslides. And the green ones are pre-existing landslides. The red dots are all of the new landslides. So again, comparing older photographs with current photographs to find out the age of the landslides. Next one. And we can also make a 3-dimensional model. You can see all the camera positions. That's the position of the photographs. So we can build all of those with a computer. We can put all of those photographs in, and we can build a 3-dimensional model with all of the positions. So, and from that, the little crosses are measurement points. So we can get the width and size of each of the landslides. We can map the run out as well. And from that, we can build an inventory and work out. I can also measure depth from that as well. That's not shown on there, but there's, so from that, we can work out estimate the volume of the landslide. So again, it's an inventory. Next one. Now, another slightly different project. This is from the UAE. Here, for this one, there was a 10-kilometre road and tunnel alignment being built across desert terrain. The good thing about deserts, so there's no trees. So we've got a very good ground exposure, which for trying to do mapping is actually better. Next one. So this is the sort of terrain that we're dealing with. Very difficult to access. They wanted a joint survey, a survey of the rock conditions across 10 kilometres of road and tunnel. And they said, how long would it take you to do it? Well, I said, well, how much for helicopters to get access to drop down and everything. Huge costs. All we can do with photographs. So I persuaded them to spend $50,000 on an aerial survey of the road alignment to get high quality aerial photographs and a LiDAR survey. Now, a LiDAR is basically it's a laser that shoots a beam down, get a return, and you can measure the position. So you end up with a point cloud of dots. So we had the photographs and I had a LiDAR survey. So next one. And this is an example of the photograph. Now, what we can do with those, we can actually measure 3 coordinates, 3 points on a rock surface, and that will allow us to measure the dip and dip direction of the rock joints. Now, across this project, I measured about 12,000 dips. Next one. And in addition, I was also able to I have a stereo system, it's a surveying system. So I've taken a surveying system and I'm applying it to geotechnical engineering. And so this shows the green lines are breaks in slope. So that's angular changes of slope. The white lines are the ridge lines, and the green and the purple dots are all of the plane joint orientations. So we're getting an idea of the bedrock structure for the whole project. And this is a stereo pair. Next one. And from that, we can also produce a 3-dimensional image with a number of the bedrock structures shown on that. So next one. And this is the last slide I've got. And then we can also take statistically all of these joints, and we could give that to an engineer, and they can then design their tunnel on this, the parameters to do with the rock. So that's this is mixing a surveying technique with engineering and with geology. So we're putting them all together as a multi-expertise field. Okay, well, that's as much as I want to talk about for today. Has anybody got any questions?
I enjoyed your talk. Thank you very much. David Anderson is my name. When did you begin doing this? What year? How long have you been at this?
I started in 1973.
I get the impression that you go worldwide doing this work.
Yes. A little bit of personal history. I said my dad basically got me interested in flying. I did geology at university, but I actually did a double degree. I did a geography degree and a geology degree at the same time. And I actually did a minor in soil mechanics as well, because I could see that there was benefit in integrating geology and earth surface processes, geomorphology, and being able to talk to engineers. So you need to know soil mechanics. I then went on and did research on landslide distributions in Southeast England for a while. And I then got a job in Hong Kong, and I was working with Kevin Stiles on mostly site histories, but we were interested in landslides because that was a big problem in Hong Kong. And when we put one of the things I started getting interested in was trying to quantify geology, because geology is a very abstract art, but I was trying to see how we could make it more accurate. So I got the RC-10, put it on the helicopter, we took the photographs, and then we had to take those photographs to the lands department, who had the big mechanical stereo plotters, and I got them to measure the points on the joints, and from that we were able to work out the joint orientations. But that got me hooked on being able to improve the quantification of geology. And so when I left Hong Kong, I went to Curtin University and I did a PhD in surveying and learned how to do photogrammetry. And so I now have what I had to go to the lands department and use a big plotter for. I have that all on my laptop. So I can basically measure points and do things with those points.
Where's your home base?
Down the road. To
Okay, so
Melbourne.
you're Melbourne based,
I'm
but
Melbourne now, but I was in Hong Kong. I left Hong Kong in 1997 with the handover, and I went to WA. I taught at Curtin University, and did a few other jobs as well. And then I came to Melbourne 7 years ago. But I've always been very interested in multidisciplinary, cross field work.
does the military ever approach you and tap into your expertise?
Not to my knowledge.
I know you'll have to kill me. You'll have to kill me. I know once you give me the
No,
answer.
no.
I'm listening.
No. But having said that, I know some of the best geologies in the Second World War was actually done on image interpretation, looking at, for example, where could you drive a tank? So if you've got this particular terrain, how do you get across it? And so geology became very important in the Second World War when they were looking at accessibility. It's an absolutely vital part of military strategy.
When I was at school in Watsonia back in the 60s, I vividly remember going out at recess time and seeing industrial airways, Lockheed Hudson's, way in the sky, going back and forth doing aerial photographs. That was back in the 60s.
Yeah. If you look out of your window across Melbourne now, you'll see some light aircraft doing exactly the same thing. There's a company called Nearmap who take photographs every 3 months, every street, and they are building an absolutely very detailed inventory of everything in the city.
They show up on flight radar. You can plot them quite regularly.
Yeah.
Someone else's turn.
Thank you, Andy, for that talk. My name is Prasad. Earlier on in your presentation, you had some the early area of photography. What were the exposure times for ones like the kites and the pigeons and whatnot?
I think I don't know. It's not recorded historically. I think the emulsions in those days were not as fast as current emulsions, but they had to be reasonably fast because the kites are moving. So they had a fixed focal length lens. So it would have been a clockwork mechanical shutter. I would imagine a 60th of a second, something like that. It wouldn't have been 1,000th or anything like that. So I think when they said the earliest balloon photography had 8 photographs and only 1 was usable, I think that was because the other ones were so blurred that it just wasn't.
That's right, because earlier on you talked about the first one, which the first ever recorded photograph, which was it 8 hours?
That was 8 hours. That was out of the studio window.
But then the daguerreotypes, how long? So they're about 1/60th of a second for the daguerreotypes.
No, the daguerreotypes.
Yep.
You think the only person who's there was having his shoes cleaned. So
Right,
how
yes.
long does it take someone to have their shoes cleaned? A couple of minutes.
That's right.
So it would have been that. It would have been minutes, not seconds.
Right, so daguerreotypes minutes, but then still, even for those other early ones.
Which is why when you see the very old photographs, they have the big flash guns, because the other way of shortening the exposure time is to have the lens open, have a big flash, and then that gives you the exposure instead of the time.
Andy, David Fredericks here, Fredo with the Royal Australian Air Force. Fascinating presentation. We've actually got an author at the moment writing a book about the use of photography in World War I from our squadron. So fascinating to hear the perspective you brought. Just a couple of things. One, the lightning you showed there, and probably just for future reference, if you refer to it again, when you talked about it carrying the reconnaissance markings, they're actually the invasion markings that was happening. Right. So that's just one thing. And I suppose the other thing is for everyone to be aware of, obviously during the period of Timor in the late 90s, early 2000s, the RAF was tasked to fly F-111s, our reconnaissance F-111s over East Timor. Now, one of the aircraft that did those flights is going to be into the War Memorial once it's been redone. So it's currently sitting in storage in Canberra. But we also found rolls and rolls and rolls of film that were taken from that aircraft. We've donated those all to the War Memorial. The challenge is the technology to interrogate that film is very rare these days, given the film, the equipment that was used. But I thought people might be interested to know that hopefully when the War Memorial's reopened and the new galleries are in place, I'll be able to go along and look at some of the vision that was taken by the F-111s flying over East Timor. Thank you.
Okay, I can just add a couple of things to that. Firstly, thank you for the correction. I've got a lot of my research out of books. So the book that I referred to was actually had that invasion marking wrong. So thank you for that correction. I'll definitely deal with that. One of the pieces of equipment that we had when we started working in Hong Kong, we set up an air photo interpretation unit from absolute scratch. And it was recognized as being quite important that well, very important that we did, because we were looking at the landslides following a couple of major landslide disasters in Hong Kong, one at Sao Mau Ping and one at Poshan Road, both of which killed between 60 and 80 people in a single incident. And so they knew that there was a problem with construction in Hong Kong. And a lot of it was to do with old, unrecognized fill slopes. And one of the things we obtained was a stereoscope, which had a movable lens and a big film roll. So we could actually put the raw film on the transparency film on this carrier and move across and actually do stereo interpretation on the original film without having to go through paper prints. And so that might be something that that might be useful for those rolls of film that the person was talking about.
Great. Thanks, Andy.
Roderick has his hand up.
Thanks. Fascinating talk. It's just about all of those elements. I've got a background in a lot of them, but I never had to put them together professionally. The thing that interests me with the photography, particularly as we move into satellite imagery, is how atmospheric haze affect the quality of your of the inputs.
Well, yes, it does affect the quality of the interpretation, but one of the things I do when I'm teaching the subject, particularly for air photo interpretation, is that we have to teach the students to think about the photographic conditions that the original photographs were taken under, because the same object can look very different under different conditions. Now, black and white photography, which is what most of the older photography is less prone to haze than the color photography. You can always enhance the colors in the processing, and digitally you can do haze removal. Atmospherics is actually more of a problem with GPS signals than with the actual imagery themselves, because the imagery can be very variable based on exposures anyway.
Right. Very quickly, what does LiDAR do that makes it superior to normal photogrammetrical exercises? What does LiDAR do to benefit those?
Well, the main benefit of LiDAR is the sheer quantity of points that can be generated. You fly LiDAR over a city, for example, and you can get 1 point every 10, 20 centimeters. The LiDAR devices fire millions of points a minute. They're very, very fast. And each point has a three-dimensional coordinate, a position, which means you can actually fire them through trees, and enough of them will get through And you see it as if when you look at them in the software, you see it as a three-dimensional model. And so if you want the ground, you basically just look at the lowest points, and everything else is vegetation or the sides of buildings. And so you can use those to identify the ground. If you do that with photogrammetry, a stereo, if you're using an automated stereo system, they do something called image matching. They will take the pattern of pixels on one image and find the corresponding pattern of pixels on another image. Now, the trouble with vegetation is the gaps in the vegetation are so small. It's difficult for these automatic systems to work. If you're doing it manually, you can see the ground through the vegetation. You can manually move your stereo image and measure the point. But that's very time consuming. I know because I do it a lot. If you're doing it with LiDAR, you're getting thousands of points per second. So it's a data processing thing, really.
Can I just please follow that? How does it perform in jungle?
Depends on the density of the trees. One of the things with LiDAR is that the gun will fire in a fan. So as you fly along, some of the photographs, some of the dots are being fired out sideways. Now, if you fly up and down, even in quite dense jungle, there will be enough points being fired in a wide range of directions that some of them will get close to the ground. So it's a statistical problem. If you throw enough points at a problem, some of them will get through.
So the computers.
Roger probably wants to try to find some World War II crashed aircraft in New Guinea.
It probably would work if the problem is going to be the cost of the survey.
Yes,
but it would probably work. But it might be.
No, actually, my interest is in a couple of fields, but one is on an area where a World War II crash did occur near Mitchell River Mission, now known as Kawanyama in far north Queensland.
Yes.
And I understand the people interested in finding the site have been endeavouring to have a LiDAR survey done. I do not know whether they've yet had that done, but that was one of the points of interest.
Okay.
And the other point of interest is in a possible application of a tunnel exercise through jungle area. And I'm very keen to hear that you have integrated that geological matter of examining ground surface. And in this case, it's a pretty dense mountainous area.
Okay, well, I could give a parallel example to that, which is I was looking for a landslide at the back of Ipswich, and I was using LiDAR data for there. And what I was looking for was the tension cracks before a major landslide occurs. So when the ground just starts moving, you get these cracks in the ground. And when I got the LiDAR from the surveyors, one of the things that they were doing, because they like smoothing everything, because smooth data sets make better maps, but they were throwing out the data that was showing the tension cracks. And if you're going to look for something like wreckage in a jungle, what you want is the high resolution, high frequency data, not smoothed. So don't give it to a surveyor. What I'm saying is there are techniques for, you've got to know what you're looking for to process the data in the way that will give you the results. Otherwise, you actually you won't get the best results. So in theory, it's possible, but you have to have someone who knows what they're doing processing the data.
Thank you.
I live in Watsonia and I don't live far from where this new Northeast Link is coming out. It goes in at Balleen and it comes out at Watsonia. About 2 years ago, there was a Britten Norman Islander constantly going the length of Greensboro Road and up to where the M80 joins Greensboro Highway. And I suspect that it was taking a series of photographs. You weren't involved in that at all? No.
No.
Yeah. Being interested in aeroplanes, it caught my attention. And it was there for probably maybe 3/4 of an hour,
Yeah.
constantly doing these. And each circuit, it moved a little further,
Across, yes.
just a little further over
Yes.
each time.
Yes.
So I figured it was doing some sort of mapping,
It
which
be,
would
yeah.
have something to do with this,
There's a alignment.
the
Yes.
new north-south.
Yes.
Yeah.
Andy, from the side of the HSA, thank you very much for being our speaker tonight.
You're very
I
welcome.
certainly do appreciate it. And I'd like to just present you with a couple of copies of our journal.
Thank you.
Our editor, of course, up the back is smiling as a result.
Thank you very much.
There he goes. And we're also going to have you as an honorary member for the next year, receiving both our journal and our quarterly newsletter as well.
Thank you very much.
A fascinating subject. I do once again thank you very much for a great talk.
Thank you, Roger.
Okay.